Hello all, welcome to the Linux Rootkits for Red Blue Team's course on Pentester Academy. Now in the last video, we saw how to make a simple Hello World kernel module. Now in this video, we are going to extend that so that the messages which we print include the name of the file, the function name, and the line info. Now, why is this important? Well, as we move along in these videos, what you would find is having the ability to print out meaningful messages can help you a lot in debugging problems in general with programming and definitely more so with kernel modules. But you can well imagine that if you have to go ahead and print stuff out, it's very easy as your module gets complicated to be able to locate things if you could also include the name of the module, the line number, function name, etc. And that's what we are going to do in this video. So let's jump right in. So I've rebooted my machine since the last lab exercise. You want to create a new directory. Shall I just copy this out to 002? Let's call this Hello World FMT for format. Let's go inside the 002 directory. First of all, move this file to hello world fmt.c. and then open up my make file. Make sure the object file name also changes to hello world-fmt.o. So this is pretty much all we would have to do. Let's make sure that the file is compiling fine. So the kernel root location remains the same. Compile it. Okay, great. Of course, this is still containing the old code. I'm just verifying that the make file and everything was changed properly. Now let's actually open up the C file. Now what I want to do is to go ahead and print out the name of the module, which is the module name, followed by the function where we are printing the info, followed by the line number. So the way we do this is basically going ahead and creating a printing format for printk. So here is what I'm going to do. Create a hash define pr_fmt. So kbuild_mod name is basically the module name, and that gets substituted here when we are compiling. And after that, we'd like to print the name of the function here, $%d, $%d, the line number, give some space. So we can use __func__ to substitute the function name, and __line__ to get the line name. Fantastic. So now what would happen is anytime we are using PR info, this would end up getting prepended. So we'd actually see the module name with an arrow pointing to the method name, which is this lkm_init, and then colon followed by the line number, right? Whatever is the line number. So let's go ahead, compile this. Oops. Actually, just make sure. Okay. So because we are kind of overloading PR underscore formats, if you look at the message over here, print K, it already has this defined, print K.h already has this defined. So what we're going to do is make sure that we include this first before any of the includes are put in. That's all we'll have to do. There we go. Now let's actually open up a new terminal so that we can monitor the kernel logs as we insert it. So I'm going to do a tail-f var log kern.log-n0 so that I can monitor just the newer entries. And let's do a sudo insmod helloworld format.ko. And if you notice, we ended up entering this onto the system. And in the kernel log, of course, there are some messages here loading out of tree module, and we'll talk about out of tree and in tree compilation and all that a little later. But of course, along with that, we are going ahead and putting in something which doesn't have a signature and all that stuff, which we'll talk about again later. The key thing to note here is this part here. So we have the module name, which is hello world underscore fmt, arrow followed by basically the name of the function followed by the line number. And after that, we have the message, hello cruel world of kernel programming, right? So if you were to open up that file, and compare this, you would actually notice that lkm init is the function as expected. This is actually there on line 11 as expected. Fantastic. So you can already see the value that anytime you're putting out these messages, it's actually telling you where the message is, which means you could even have exactly similar messages in different parts of the code, and you would end up knowing where it is actually getting called, right? Now, similarly, let's actually go ahead and remove the module. Let's do a rm mod. And when we do that, if you notice, automatically this part gets populated and it says, wow, you exited early. Fantastic, right? Now, one of the other things which I like to do when I do all of these debug messages and everything is have a message which basically defines where we are in the code. So the whole idea is that anytime I call, let's say, PR info, I am here, it automatically just kind of goes ahead, prints out that message. Okay. So I'm going to define a very simple macro to do that. I'm going to call that macro I am here, rather than calling PR info every single time. And internally, of course, it would end up calling PR info. Now, one important thing to note is anytime you're using PR info, at the end, make sure that you go ahead and have a new line. If you don't do this, sometimes what may happen is this message might get buffered, and only when something else is written will this actually get printed out. But doing a /n ensures that it pretty much gets written to the log file. Okay, so this is important, and that's what we've done here. Now, once I've defined I am here, we can once again do the same thing. Say I am here before returning. Then can type in I am here about to exit, right? Now, when we compile this and do a sudo insmod, make sure we are monitoring. Let's put this in. And if you notice, we get the first message, but after that we get our I am here one as well. And let's actually go ahead and remove it. And there you go. We get our I am here. Now these I am heres are very interesting because they actually make your life very easy. And if you've done a fair bit of programming, you know what I mean. A lot of times when you're actually debugging stuff, you quickly want to figure out if certain code paths have been traversed. And this is where this comes in extremely handy, right? So I'm going to be using both of these as we move along in the videos, just so that it can actually help us out. Now keep in mind, there are also many other ways by which you can debug, including runtime debugging, where you can have two instances, one instance going ahead and debugging the other kernel instance and all of that stuff. So I think for our purposes, we may not have to go into that much of detail. What we could do is maybe in a separate course, I can actually take up kernel debugging when I'm planning to create a Linux kernel exploitation class, right? Where we can look at vulnerabilities in the kernel and how to exploit it. For the purpose of this course, I think debug messages should be sufficient, and we don't have to go into low-level kind of kernel debugging, which is again a topic in itself and not to be taken lightly. Okay, fantastic. So I hope you enjoyed this video. The first couple of videos, as you're seeing, is just looking at the basics of kernel modules and how to begin working with them. This is important because you're probably thinking, where is the rootkit basics and where are all the interesting demos? They will come, but I think I'm going to dedicate a couple of more videos for you to understand the basics of LKMs and how to work with them. Then we'll jump into the action and you'll see that we are going to pack a lot of heat very soon. Thank you.